Welcome to the Sleepy Cosmos channel, a place where science and serenity meet. Here we explore the quiet wonders of the universe, from dark matter to string theory, all told in a calm, soothing rhythm designed to help you relax, drift, and dream among the stars. Each video is a guided journey through the cosmos, slow, meditative, and filled with real science wrapped in gentle storytelling. So if you love space, curiosity, and the peaceful side of knowledge, you're in the right place. Make sure to subscribe for more new sleep narrations every week. And if you'd like to reach out for collaborations or business inquiries, you can contact us at the sleepycosmoschannel@gmail.com. Now, settle in, take a deep breath, and let's drift into the universe together. Settle gently into stillness. There is no urgency here. No need to follow anything closely, no task to complete, no conclusion to reach. Only a quiet invitation to rest and to let your attention soften. You may notice the simple fact that you are here, breathing present, occupying a small moment in time, and even without effort, that moment is already changing. Time does not announce itself. It does not arrive with sound or motion. It does not ask for permission. It simply moves forward. You have never watched a moment reverse itself. You have never seen the present gather itself back into the past. You have never experienced tomorrow arriving before today. Not once. This is not something learned from textbooks or measured with instruments. It is something lived, quietly, continuously. The universe moves forward, and so do you. Tonight is not about solving time or arguing with it or questioning whether it exists. Tonight is about resting inside a single, gentle observation. Everything changes in one direction. You might notice this in the smallest things. A breath enters the body and then it leaves. Warmth spreads from a source, but does not gather itself back again. A sound fades and does not return to silence in reverse. These changes are not dramatic. They are not sudden. They are not violent. They are calm, ordinary, reliable. A glass of water spills and the water flows outward across a surface into countless tiny paths. You have never seen that water pause. Consider its options and quietly return to the glass. Smoke rises and spreads and thins until it becomes part of the air. It does not gather itself back into a single plume. Ice melts, slowly, patiently, transforming into liquid. But not once does a puddle grow colder, reassemble its structure, and become ice again on its own. These are not failures of imagination, they are clues. The universe prefers certain directions, not because it chooses, but because of how possibilities unfold. This direction is sometimes called the arrow of time, but it is not an arrow in the sense of speed or force. It does not pierce or rush. It is more like a quiet slope, so gentle you rarely notice it, yet impossible to climb without effort. Time is often imagined as a clock, as ticking, as counting, but that is not what guides the universe. Time is not a number, it is not a dial, it is not a mechanism, it is a direction of change. The direction in which things spread, settle, fade, and leave traces. You live inside this direction, and because you live inside it, it feels natural, invisible, almost trivial. Memory moves only one way. You remember moments that have already passed, but not moments yet to come. You can imagine the future, predict it, plan for it, but you cannot remember it. This is not a limitation of your mind, it is a property of the universe. Every memory is a record, a physical change in matter, a pattern stored in the brain, and records can only form in one direction. You may notice that the past feels solid, fixed, certain, while the future feels open, unsettled, unwritten. This difference is not psychological accident, it is physical law quietly expressing itself. Tonight's journey does not require you to stay alert or to hold these ideas tightly. They can drift like slow clouds, passing through awareness. There is no paradox waiting ahead, no confusion to resolve, no sudden twist, only a gradual unfolding like the universe itself. Time will not be presented as an enemy, nor as a mystery that demands fear. It will be allowed to be what it already is, a steady movement toward what is more likely. As you rest, your body continues to change. Cells exchange energy, heat moves gently outward, breath flows in and out. Even in stillness, change continues. This is not something to resist, it is something to rest within. The arrow of time does not rush you forward, it carries you. You do not need to push, you do not need to keep up. The universe is patient. Tonight, we will let go of the idea that time must be mastered or measured or conquered. Instead, we will allow it to be felt as a quiet background, supporting everything. You may notice that as attention softens, the sense of time begins to loosen. Moments stretch, edges blur, the present feels wider. This is not time slowing, it is awareness changing. As the mind relaxes, it stops counting, stops predicting, stops holding, and in that release, time becomes less sharp. There is nothing unusual about this. It is part of how the brain rests. Sleep itself is not an escape from time. It is a different way of moving through it. As the body settles and thoughts drift, the arrow of time continues, quietly uninterrupted. There is comfort in this. The universe does not hesitate. It does not second guess. It does not rewind. It simply unfolds, and you are part of that unfolding. You do not need to follow every idea or remember every sentence. These words are not instructions. They are companions. If your attention wanders, that is perfectly aligned with the direction of everything. If thoughts dissolve, that too is natural. Nothing here demands effort. The arrow of time has been moving forward since long before you arrived, and it will continue long after. Yet in this moment, it carries you gently, without expectation. There is no finish line tonight, no destination, only a slow movement toward rest. And as you drift, you may begin to feel something subtle, a sense that forward does not mean faster or louder or brighter. It often means quieter. Stillness is not the absence of change. It is a form of balance within it. You are allowed to rest, while the universe continues its gentle work. Nothing is required of you, except to remain here, as long as you wish. Time will continue calmly, inevitably, and you may simply let yourself move with it, without resistance, without urgency, without thought, just forward. As everything does, let the idea settle gently, that the direction of time, the feeling that life moves forward, can be traced to something quiet and ordinary, a tendency, a statistical drift, a soft preference in the way matter and energy rearrange themselves. There is a word in physics that often appears when people ask why time feels one way: entropy. And despite how technical it can sound, it is describing something you already understand in your bones, not as a formula, not as a harsh rule, but as a simple pattern. Things spread out, differences even out, arrangements become less special and more typical. It can be helpful to begin with something gentle, a way of thinking that does not require mathematics. Imagine a handful of tiny pieces, like grains of sand. If you place them carefully into a neat line, you have created something specific, a rare arrangement. If you shake the table, the grains scatter, they form a random pattern. Not because randomness is powerful, but because there are so many more scattered patterns than neat lines. Entropy is closely related to this idea. How many different microscopic ways a system can be arranged, while still looking the same at the scale you notice. The word microscopic matters here, because the universe is built from unimaginably many small parts, atoms, molecules, particles, and the motions of these parts, the exact positions and speeds, can be arranged in countless combinations. A single cup of warm tea looks simple, but inside it, molecules are moving, colliding, rotating, vibrating. There are more possible internal arrangements than the mind can picture. Entropy, at its core, is a way of describing how many internal arrangements are available, how many hidden patterns are compatible with the same visible state. A low entropy state is one that can be realized in relatively few microscopic ways. It is special, constrained, ordered in a particular fashion. A high entropy state is one that can be realized in many microscopic ways. It is typical, broad, easy to reach. And this difference between rare and typical is what gives the arrow of time its steady direction. Because systems tend to move from rare arrangements to typical ones, not by decision, not by intention, but because there are simply more ways for typical states to exist. If you release a system, if you stop holding it in a special configuration, it will drift toward what is easiest to realize, toward what has more possibilities. This drift is the quiet engine behind the arrow of time. Now let this stay gentle. Entropy is often misunderstood. People hear the word and think it means decay, or disorder in the emotional sense, or moral decline. But entropy is not a judgment. It is not the universe saying something is worse. It is the universe counting possibilities. A neat arrangement is not morally better than a scattered one. It is simply less common, less likely to appear by accident, and because it is less common, it is also less stable. It requires conditions to maintain. If those conditions fade, the arrangement loosens, and the system drifts towards states that can be realized in many ways. This is why low-entropy states are fragile, not because they are weak, but because they are narrow. They occupy a small region in the space of possible arrangements. High-entropy states are robust, not because they are strong, but because they are broad. There are countless routes that lead into them, and comparatively few routes that lead out. This can be felt in a simple example: ice melting. Picture a glass with ice. At first, the water molecules in the ice are locked into a crystalline structure. They are not motionless, they still vibrate, but they are constrained. They occupy a patterned arrangement. As the ice absorbs heat from the surrounding air, those constraints weaken. Molecules gain energy and begin to move more freely. The crystal pattern breaks, and the ice becomes liquid water. The liquid state has vastly more possible microscopic arrangements than the solid crystal. The molecules can slide past one another, rotate, trade neighbors, form and break tiny structures moment by moment. So the liquid is a higher entropy state than the solid, not because it is messy, but because there are far more ways to be liquid than to be a perfect crystal. When the ice melts, the system is moving toward a state with more possibilities. You can reverse it. You can freeze water into ice, but you must remove heat. You must do work indirectly, perhaps by running a freezer that consumes energy and pushes heat outward. The reversal is not forbidden, but it is not something that occurs spontaneously in a warm room. In a warm room, heat flows into the ice melts. That is the easy direction, the direction of increasing entropy overall. Now consider a second example: heat spreading through a room. Imagine a small heater warming one corner. Near the heater, the air molecules move faster on average. Farther away, they move slower. Over time, collisions spread energy outward. Fast-moving molecules collide with slower ones. Energy disperses. The temperature becomes more uniform. This is another drift toward a more typical state. A uniform temperature is not just even in a human sense. It is a state that can be realized in many microscopic ways. Because energy has been spread among many molecules, rather than concentrated in one region, the concentrated state, where warmth sits neatly in one corner, is a special arrangement. It can exist while the heater maintains it. But once the heater is off, the system drifts, heat flows, gradients flatten, differences soften, and again, you can reverse it, but only by doing work. You can create a cold region inside a warm room. A refrigerator does it every day. But the refrigerator must consume energy, and it must dump more heat into the room than it removes from the cold compartment. The total entropy still increases. The arrow is still respected, even when you create local order. A third example is also very gentle: gas filling a container. Imagine a container with a divider, gas molecules on one side, empty space on the other. If the divider is removed, the gas spreads, molecules move into the empty region, they bounce, collide, and soon the gas fills the entire container. This feels obvious, but it is also a deep illustration of entropy. When the gas is confined to one side, there are fewer possible microscopic arrangements. The molecules may move in many ways, but they are restricted in location. They cannot occupy the other half of the container. When the divider is removed, the molecules can occupy the whole space. And because there are vastly more ways to distribute molecules across the entire container than to keep them all on one side, the system drifts. In principle, the molecules could all return to the original half. There is nothing in the fundamental laws that screams no, but it would require an extraordinary coincidence. Every molecule would need to move in just the right way, at just the right times, without any deviation. The odds are so small that it is effectively never seen, not because it is impossible, but because it is so unlikely. This is a key idea. Entropy is not always about what is allowed, it is about what is overwhelmingly favored, and this is where time enters, because forward is the direction the universe tends to drift, from less probable arrangements to more probable ones, from constrained states to unconstrained ones, from low entropy to higher entropy. When we say entropy increases, we do not mean that everything becomes chaotic. We mean that the number of available microscopic arrangements increases, and that systems tend to move towards states with many arrangements. Now, pause inside that idea for a moment. It is quietly beautiful, because it means the arrow of time is not a mysterious engine pushing reality. It is a pattern emerging from counting, from combinatorics, from the simple truth that large systems have many more typical states than special ones, and the universe is the largest system of all. This also explains why entropy increase does not require intention. A system does not need to try to increase entropy. No molecule aims for it. No atom understands it. Atoms do not know the future. They do not know the past. They do not hold a concept of direction. They simply obey local laws. They collide, exchange energy, follow forces. And yet, when you have enormous numbers of particles, the collective behavior becomes directional, not because the laws changed, but because probability takes over. In a small system, chance fluctuations can be noticeable. In a large system, the statistics become overwhelming. A handful of molecules might randomly cluster for a moment, but a room full of air does not spontaneously compress itself into one corner. The numbers are too large. The space of possibilities is too vast. This is why entropy is often described as a statistical law. It is not a prohibition, it is a near certainty. Now, there is something subtle here that can feel calming once it is understood. The fundamental laws of physics at the microscopic level are mostly reversible in time. Meaning, if you filmed two molecules colliding and played it backward, the collision would still look physically plausible. This can be surprising, because our experience is so strongly one-directional. But the key is scale. Microscopic reversibility, macroscopic irreversibility. At the microscopic level, interactions can often run forward or backward without contradiction. But at the macroscopic level, where countless particles are involved, the reversal would require a precision that reality does not provide. To reverse a broken glass into a whole glass, you would need every shard to move exactly back, every vibration of air to rewind, every tiny heat exchange to reverse. It is not that one shard cannot move back. It is that coordinating all of them is astronomically unlikely. Macroscopic irreversibility emerges because macroscopic states correspond to many microscopic configurations, and most of those configurations look like the spread-out version, the mixed version, the equilibrated version. So even if the underlying laws do not forbid reversal, the universe almost never finds the precise microscopic pathway back. This is how time's arrow can exist without being written into the basic equations as a separate rule. It is an emergent direction, a direction that appears when you zoom out. Now let this connect to something gentle and familiar, your breath. Breathing is a flow. Air mixes, molecules diffuse, heat exchanges between lungs and blood and surrounding tissue. Each breath is a small thermodynamic event, a redistribution of energy and matter, and your body, in general, is an engine, not in a harsh mechanical sense, but in a physical sense. It takes concentrated energy from food and oxygen and converts it into motion and warmth, and in doing so, it increases entropy overall. This is not negative, it is what allows life to exist. Life maintains local order by exporting disorder to the surroundings. Your body keeps patterns intact, cells, tissues, neural connections, but it can only do that while energy flows through it, while heat is released, while entropy increases in the environment. This is one of the most important clarifications. Entropy does not mean everything becomes more disordered everywhere. It means the total accounting trends toward more possibilities. Local structure can increase. A baby grows, a tree forms rings, a city is built, a brain learns. These are real increases in local order, but they occur because larger gradients are being used. Sunlight falls in concentrated form, food stores chemical energy, fuels burn. Those energy sources allow work, and the byproduct is heat spread into the environment. Entropy increases overall, even as islands of complexity appear. This is why entropy quietly governs everything from stars to breathing organisms. Consider a star. A star shines because there is a gradient, a difference. In the core, pressure and temperature are extreme. Fusion converts mass into energy. That energy flows outward, moving from hot to cooler regions, eventually radiating into space. A star is not a static object. It is a process, a long thermodynamic flow, a sustained imbalance slowly relaxing. The star's existence is a story of entropy. a conversion of concentrated nuclear potential into radiation spread across enormous volumes. And that radiation, once released into space, disperses. It becomes part of the universe's background. A star is a fountain of increasing possibilities. Even when stars create heavier elements, even when they create planets, even when they help create chemistry rich enough for life, the overall story remains one of energy spreading. Entropy is present in the slow evolution of galaxies, in the cooling of planets, in the mixing of oceans and air, in the fading of fires, in the smoothing of temperature gradients. It is present even in the simple act of opening a door. Air mixes, pressure equalizes. And it is present in the quietest corners of life, the warmth that gently leaves your skin into the room, the way a hot drink cools, the way a scent disperses, the way a sound fades. Now, let's return to the idea of low entropy being rare, because this rarity is one of the reasons the arrow of time feels so consistent. A low entropy state is a special arrangement, like a deck of cards in perfect order, like gas confined to one side, like a clean division between hot and cold. These states do occur, but they often require a history that produced them, or a constraint that maintains them. A freezer maintains a temperature difference. A lid maintains a separation between a gas and open air. A dam maintains a reservoir. A battery maintains a charge difference. But once the constraints are relaxed, the system drifts, and it drifts not out of malice, not out of failure, but out of vast numerical preference. The high entropy state is not a destination chosen. It is simply what most arrangements look like. This is why high entropy states are common and stable. If you disturb them slightly, they remain high entropy because you are still in the broad region of typicality. Low entropy is like balancing on a narrow ridge. There are many ways to fall off and very few ways to stay perfectly aligned. Now, if you allow this to sink in, it offers a calm reframe of the arrow of time. Forward is the direction in which the universe moves from narrow regions of possibility to broad ones, from special to typical, from constrained to unconstrained. This is why you do not see a spilled drink leap back into a cup, not because the universe is cruel, but because the spilled state corresponds to vastly more microscopic arrangements. There are countless ways for droplets to be scattered across a floor, countless ways for the surrounding air to be jostled, countless ways for heat to be distributed. There are very few ways for every droplet to return to the cup, in the right order, without leaving any trace, without stirring the air incorrectly, without producing the wrong heat pattern. So the arrow of time is the arrow of probability. And because we live inside that probability, it feels absolute. Now bring this back to rest. You do not need to hold the definitions tightly. You do not need to remember the examples perfectly. The purpose is only to let your mind feel the shape of the idea. Entropy is the measure of how many ways things can be arranged inside, even when they look the same outside, and time feels one-directional, because systems tend to move toward states with more internal possibilities. This is the quiet foundation beneath the forward motion of experience. Even now, as you lie still, heat is spreading gently from your body into the room. Molecules in the air are colliding, mixing, sharing energy. Nothing about this is urgent. It is simply what matter does. And as your attention softens, you may find it calming to know that the arrow of time is not a harsh command. It is a statistical drift, a gentle tilt in the landscape of possibility. Forward is where the vast majority of paths lead, and you are allowed to rest as the universe continues to choose, not by intention but by numbers, just drifting into what is most likely, with no effort at all. There is a gentle paradox that often appears when people first learn about the arrow of time. The world you experience feels unmistakably one-directional. Spilled water spreads, warmth diffuses, smoke disperses, memories point backward. And yet, when physicists write down the deepest, simplest laws we know, many of them do not clearly prefer past or future, at least not in the way experience does. This does not mean experience is wrong. It means the arrow of time is not written in the same place you might expect. It helps to begin with something small, something simple. Imagine two smooth balls colliding on a table. If you watch the collision, one ball approaches, they meet, they separate, moving away in new directions. Now imagine you filmed that collision and then played the film backward. The motion would still look plausible. A pair of balls approaches one another, touches, and separates. Nothing about the backward version obviously violates the basic mechanics. This is the quiet idea behind time symmetry. At the level of many microscopic interactions, the laws look compatible with both directions. This is not always true for every detail of nature, but for much of everyday physics, the basic equations do not stamp a clear label that says, this can happen only forward. So how can a one-way experience arise from laws that seem indifferent? The answer is not a hidden force, not a mysterious clock, not a cosmic instruction. The answer is scale and probability. When you have only a few parts, reversal is not so strange. You can often undo what happened. If you bounce a ball, you can bounce it back. If you push a pendulum, it can swing back through its own path. But as soon as you have many parts, the world becomes different. Because macroscopic events are not made of one collision, they are made of countless collisions. So many that you cannot track them, so many that you cannot coordinate them, so many that no practical process can aim them all in reverse. A broken glass is not a single event. It is an explosion of microscopic details. Tiny fractures, shards moving, air molecules pushed aside, vibrations in the floor, heat created by friction, sound radiating outward. To reverse a broken glass, you would need to reverse all of that. Not only the visible shards, but the air that moved, the sound waves that escaped, the heat that spread into the room. The point is not that this is forbidden. The point is that it is unimaginably specific. Time symmetry at the microscopic level does not automatically create symmetry at the macroscopic level. Because macroscopic states correspond to huge numbers of microscopic possibilities, a macroscopic description is coarse. It speaks in broad terms. A room is warm, a cup is broken, smoke is dispersed. But warm room is not one microscopic arrangement. It is a category. It includes an enormous number of microstates. Tiny hidden configurations, all of which look similar to you. The same is true for broken glass. There are countless ways the shards can be arranged, countless ways the air can be moving, countless ways heat can be distributed. Meanwhile, unbroken glass is much more specific, not in a poetic sense, in a statistical sense. There are fewer microstates that correspond to a perfectly intact glass, a narrow set of configurations that preserve that shape. So even if the microscopic laws allow many trajectories, the overwhelming majority of trajectories lead from the narrow state into the broad one. That is the heart of the asymmetry. If you want a simple way to feel it, imagine walking in a landscape. A narrow valley feeds into a wide plain. From the valley you can step into the plain in countless ways, but from the plain, finding the exact path back into the valley is difficult. Not impossible, just very unlikely. In physics, the wide plain is the space of high entropy possibilities. The narrow valley is the space of low entropy possibilities, and the arrow of time is the drift from narrow to wide, from fewer possibilities to many. This is how time can feel one-directional, even if the fundamental laws do not clearly demand a direction. It is not that laws are lying, it is that laws describe local rules, while the arrow of time is an emergent pattern, a collective outcome. A statistical drift. This drift is so reliable at human scales that it becomes the foundation of experience. And it is not only about broken objects, it is also about information, records, and what you can know. Consider a simple scene. A cup sits on a table. You look at it. Light reflects off it, enters your eyes, creates a pattern in your retina, a pattern in your brain. This is a physical process. It leaves traces. Now imagine reversing it, not only reversing the photons, but reversing the tiny changes they produced in your nervous system, so that your brain returns to the precise state it had before seeing the cup. Nothing about the microscopic laws necessarily forbids such a reversal. But it would require extraordinary coordination, because perception is not one event, it is a cascade. A cascade spreads, and cascades are hard to reverse. This is another reason time feels directional, because knowledge itself depends on irreversible processes. To learn something, to form a memory, to record a measurement, a physical system must change, and that change must leave a stable trace. Stable traces are not free. They require energy flow. They produce heat. They increase entropy somewhere. So the asymmetry between past and future is reinforced by the asymmetry between records and non-records. The past is the direction where records exist, because records are created by processes that already happened. The future is the direction where records do not yet exist, because the events that would create them have not occurred. This is not a statement of philosophy. It is a statement about physical causation. A photograph is a trace of light that already arrived. A fossil is a trace of life that already lived. A memory is a trace of experience that already occurred. So the past is not only what happened, it is also what left marks, and marks have direction. Now return gently to the idea of time symmetry, because it is important to hold it in the right way. Time symmetry does not mean the world is equally likely to run backward. It means the underlying rules often do not explicitly distinguish direction. The distinction appears when you consider probabilities, initial conditions, and the sheer number of degrees of freedom. Degrees of freedom is a calm phrase. It simply means the number of independent little ways a system can be arranged. A gas in a room has an enormous number. Every molecule can be in many positions, moving in many directions with many speeds. A single collision has few degrees of freedom. A room full of air has a vast number. And with many degrees of freedom, the number of ways to be mixed is overwhelmingly larger than the number of ways to be unmixed. So the time-reversed state is not forbidden. It is just buried among so many other possibilities that the universe almost never visits it spontaneously. It is like selecting one specific grain of sand on a beach. It can be done, but not by accident. This helps explain why experience is so consistent, why you can trust that smoke will not gather back into a candle, why you can trust that a sentence you read will remain in your mind for a little while, why you can trust that a warm drink will cool. The arrow of time gives the world reliability. And now there is a deeper layer, one that connects time's arrow not only to entropy, but to the beginning of the universe. Because you might wonder, if the laws are mostly time-symmetric, and if time's arrow is a statistical drift, then why did the universe begin in a condition where this drift had somewhere to go? In other words, why was the early universe in a low-entropy condition at all? This question can be asked gently, without urgency, because it does not need a final answer to be meaningful. It is enough to recognize that the arrow of time, as we experience it, depends on the fact that the universe had a great deal of entropy still available to increase. The simplest way to say it is that the universe began in an unusually special state, not necessarily special in terms of temperature alone, but special in terms of structure and arrangement. From that beginning, the universe has been unfolding, and along the way, entropy has been increasing, and time has had a direction. This is why the arrow of time feels so deep. Because it is not merely a feature of kitchens and weather, it is tied to cosmology, to the large-scale story of the universe. But notice how calm that can be. It means the direction you feel in everyday life is connected to the direction of cosmic history. Your ordinary experience, the fading of warmth, the dispersion of scent, the formation of memory, is aligned with the same statistical drift that shapes stars and galaxies. This is one reason the arrow of time can feel both scientific and philosophical, not because it forces a conclusion, but because it links personal experience to universal behavior. Now consider how time appears in your own awareness. Even without thinking about physics, you experience a moving present, a sense that now is here and then it is gone. But the sensation of a moving present is not a property of the equations, it is a feature of brains. Brains are physical systems, and like all physical systems, they run on energy flow. They create and maintain patterns, they form memories, they dissipate heat, they increase entropy overall. So your sense of time and the universe's arrow are not separate narratives. They are different views of the same physical direction. This can be calming because it means the forward movement of experience is not an illusion you must fight. It is the most natural thing in a universe like this. Now, let's bring the idea back down to rest. When you relax, when you stop trying to track each moment, the sharpness of time can soften. You still move forward. Your body still exchanges heat with the room. Your cells still do chemistry. Your heart still circulates blood. But awareness can stop counting. And when awareness stops counting, time can feel less like a line and more like a gentle continuity. This is not a trick. It is a feature of how the mind works. The brain is constantly predicting, updating, assembling a coherent sense of now from many signals, and as you drift towards sleep, those predictions loosen, the updates slow, the urgency fades. So the arrow of time continues, but you do not need to monitor it. That is one of the quiet gifts of sleep. It is not a pause in physics, it is a release in attention. Now, one more gentle clarification. Because it can prevent confusion, when we say the laws of physics are time-symmetric, we are not saying there is no arrow of time. We are saying the arrow is not typically written as a separate clause in the microscopic rules. The arrow emerges because the universe contains many particles, because initial conditions were special, and because the space of possibility strongly favors dispersal. So time's direction is real, and it is not merely psychological. It is written into the statistics of large systems, and reinforced by the physical nature of records, memory, and irreversible processes. This is why the everyday world does not behave like a reversible movie. A reversible movie would require a universe that constantly finds extremely rare arrangements, again and again, with perfect coordination, without error. But our universe is not built that way. It is built to explore what is typical. And typical states are the broad ones, the mixed ones, the equilibrated ones, the states with many internal possibilities. So the arrow of time becomes a quiet certainty, not because it is enforced by a cosmic policeman, but because of numbers, because of counting, because of probability. Let that settle in the way a soft idea settles. Time symmetry at the smallest scales and time direction at the scales you live are not enemies, they are layers. Local rules and global tendencies, and you are allowed to rest inside that layered reality. Nothing here demands intense focus. If your mind begins to drift, that drifting is itself aligned with the same gentle direction, from the rare and effortful toward the common and relaxed. Just settling, just loosening, just moving forward, as everything does. Let your attention rest on something simple. The past leaves marks, the future does not. This is not only a feeling, it is a physical asymmetry, one that runs through photographs and fossils, through written words and worn paths, through the structure of the brain itself. A memory can seem like something private, a soft internal image, a story you tell yourself. But in physics, a memory is not a mist, it is a record, a stable change in matter. When you remember, something in the physical state of your nervous system is different than it was before. Connections shift, patterns of activity become easier to reproduce, chemical balances change. You do not have to know the details. You do not need the microscopic map. It is enough to understand the principle. A memory is a trace, and traces have direction. A footprint exists because a foot pressed into soft ground. A fingerprint exists because skin left oils on a surface. A crack exists because stress exceeded strength. A scar exists because tissue reorganized after injury. A record is what remains after an event, and the ability for records to form is tied directly to the arrow of time. If time had no direction, records would not be reliable because the changes that create them would not accumulate consistently. But in our universe, they do accumulate because physical processes tend to produce irreversible changes, and those changes can be stabilized into records. This is why you can know the past, even if you were not there. A photograph can show you a face you never met. A fossil can show you an animal from deep time. A distant galaxy can show you light that left long before humans existed. All of these are records, and all records share something in common. They are created by a flow of energy, and that flow produces entropy. It can help to say this gently, because it sounds technical, but it is deeply intuitive. To make a record, you must change something. You must imprint a pattern onto a medium, and for that imprint to be stable, it must be supported by physical irreversibility. Writing on paper is a rearrangement of material. Ink molecules are deposited, fibers absorb, the surface becomes different. Taking a photograph is a physical interaction between light and sensor. Charges shift, chemistry changes, a pattern is fixed. Forming a memory is a physical interaction between experience and brain. Signals pass, molecules move, connections adjust. In every case, energy is used and heat is released, and entropy increases somewhere. This is not a side effect, it is part of why the record can exist at all, because stable information is not free. It must be held in place against random thermal motion, against noise, against the natural tendency of systems to drift. That holding requires energy flow. This is a deep connection between knowledge and thermodynamics, between memory and the arrow of time. When you remember something, your brain is not simply looking backward into a perfect archive. Your brain is reconstructing, using patterns that were physically laid down. Patterns that exist because physical processes ran in one direction. And because those processes ran in one direction, the record points backward, not forward. This is why you can have evidence of the past, but not evidence of the future. It is not that the future is less real. It is that the future has not yet generated traces. A footprint can only appear after a footsteps. A photograph can only exist after light arrives. A memory can only be formed after experience occurs. So the asymmetry between past and future is partly an asymmetry between recorded and unrecorded. Now notice something calming. This means your sense of time is not arbitrary, it is grounded. The brain experiences time moving forward, in part because it is built to accumulate records, and every record is built from irreversible change. This also explains why memory has a certain texture. The past feels fixed, because it is supported by traces, by stable patterns that exist now. The future feels open, because those patterns are not yet formed. This is why you can plan, but not remember. Planning is simulation, prediction, a model running in the mind. Memory is reconstruction from physical traces. They are not the same process, and this is why anticipation feels uncertain, even when you are confident, even when you believe you know what will happen. Because anticipation is not built from records, it is built from guesses, from patterns you have learned, from the statistics of past experience. Memory feels different, because memory is anchored. It is tethered to a physical trail that already exists. Now let's make this even more concrete, without becoming intense. Imagine a room, a person speaks, sound waves travel outward, they strike walls, they reflect, they fade. If you record the sound, a microphone converts pressure changes into an electrical signal. That signal is stored, perhaps as tiny changes in a magnetic surface, or in electric charge patterns. The recording exists because matter was rearranged in a way that can persist. But the sound itself does not gather back into the mouth of the speaker. Once the waves have spread, they mix into countless microscopic vibrations, into thermal motion. The sound becomes heat, distributed. It is not that the sound is destroyed, it is that the information about the sound's coherent shape has been dispersed. And this word matters, information. In physics, information is not only about human meaning, it is about distinguishable patterns, about correlations, about structure you can use to infer what happened. When a process runs forward, it tends to take information that is concentrated and organized and disperse it. A glass shatters, and the details of its original shape become hidden among countless microscopic variables. Heat spreads, and the details of where the energy started become less recoverable. Gas mixes, and the information about which molecule started where becomes effectively lost. In principle, if you knew every detail, every molecule position, every velocity, you could reverse it. But in practice, those details are not accessible, and once they are dispersed into microscopic degrees of freedom, they become unreachable. So memory and records are special. They are ways of preserving some information, despite the general drift toward dispersal. But preserving information requires work. It requires an energy gradient. It requires a system kept away from equilibrium. Your brain is such a system. It is warm, active, constantly exchanging energy, constantly maintaining structure. So memory is not an effortless reflection. It is a physical achievement. And this can be understood in a calm way. Every time a brain stores a memory, it must overcome noise, random molecular motion, thermal fluctuations. To imprint a stable pattern, it must spend energy, and that energy must go somewhere. Often as heat, so the act of recording, whether in a brain or a device, is aligned with the arrow of time. Now consider erasing, because erasing can seem like undoing, but in physics, erasing is not simply removing. It is also a physical process. To erase a memory in a computer, you must reset states. You must overwrite, you must drive a physical mechanism. To erase a mark, you rub it away. You disperse pigment into the environment. You generate heat through friction. Erasure also increases entropy, because it is itself a dispersal of structured information. So even deletion follows the arrow. This is why memory and time are intertwined. If you lived in a universe where entropy did not increase, where processes were naturally reversible, records would not be stable in the same way. The past would not accumulate evidence in the same way. You might still have change, but you would not have the same reliable trail. Our universe, because it runs forward statistically, creates a world where learning is possible, where history leaves patterns, where identity can persist. This is a gentle thought. The arrow of time is not only what makes things fade, it is also what makes continuity possible. Because continuity depends on stable traces, and stable traces depend on irreversible processes. Now bring this back to your own sense of self, without turning it into philosophy. You feel continuous, because your brain carries forward patterns from moment to moment. Those patterns are not perfect, they shift, they update, they soften, but they persist enough for you to feel like the same person who woke up this morning. That persistence is physical. It is maintained by metabolism, by energy flow, by a warm living system constantly renewing itself. So the arrow of time does not merely carry you forward. It also allows you to keep a coherent story as you move. And when you rest, when you sleep, something interesting happens. Sleep changes memory, it consolidates, it stabilizes, it prunes, it reorganizes. All of that is physical work done by a living system, and it still follows the arrow. Energy is used, heat is released, entropy increases overall. Even in sleep, records are being managed. So the arrow of time is not only something you think about, it is something you are. A living record maker, a pattern that preserves traces of the past. Now notice again why the future cannot be remembered. It is not because the future is blocked. It is because remembering requires a trace, and traces require events, and events must occur before their traces can exist. A memory is always downstream of its cause. This gives time its feeling, the sense of already happened versus not yet. And you can rest in that without needing to fight it, because it means the direction you feel in consciousness is consistent with the direction of physical record-making. The universe moves forward, and as it moves, it leaves behind a trail. That trail is what you call the past. Now allow your attention to soften. You do not need to carry every detail. If your mind begins to drift, that drift is not failure. It is a quiet alignment with the same tendency toward relaxation, toward typicality, toward ease. Memory itself can loosen, thoughts can blur, the need to track can fade. And even as that happens, the arrow continues steady, patient, leaving traces, quietly, and you are allowed to rest inside it. Let the idea deepen gently that a memory is not only a feeling, it is a physical trace, a record that exists in matter, and because it is a record, it must be made. It must be written into the world. When a record forms, something changes, not in a vague way, in a precise physical way. Atoms shift, molecules rearrange, energy moves, heat is released. Even the simplest record is not free. A scratch on a surface, a crease in paper, a dent in metal. Each one is a rearrangement, and rearrangements that persist require irreversibility. This is why the past feels like it has weight, because it is supported by a library of traces. Not only in minds, but in the environment. Dust that has settled, paint that has faded, rocks that have cooled, light that has traveled. The world carries its history, not as a story, but as structure. You can think of the universe as constantly writing, not with intention, not with words, but with physical correlations. A correlation is a quiet concept. It simply means two things become linked. If one changes, the other reflects it. A footprint is a correlation between a foot and soft ground. A photograph is a correlation between a scene and a sensor. A memory is a correlation between an experience and a neural pattern. And once a correlation exists, it points backward toward its cause. This is why the direction of time is also the direction of explanation. We explain the present by pointing to the past, because the past is what created the present, and the present contains traces of that creation. We do not explain the present by pointing to the future, because the future has not yet created traces in the present. This is a calm asymmetry, but it is profound. Now notice something else. Records are not only about permanence, they are about stability. A record must resist being erased by noise, by thermal motion, by random fluctuations. The universe is warm. Even cold objects are alive with microscopic motion. Atoms vibrate, molecules rotate, electrons shift. So to store information reliably, you must build a structure that can hold a pattern against this restless background. A carved inscription lasts because stone is rigid, because the energy barrier to reordering it is large. A magnetic memory device lasts because its physical states are stabilized, because switching them requires energy. A biological memory lasts because living systems actively maintain their structure, repairing damage, refreshing patterns, reconsolidating. So memory is never purely passive. It is not like placing a book on a shelf in a perfectly still room, because there is no perfectly still room. Instead, memory is more like maintaining a pattern in a flowing river. The pattern can persist, but it persists by ongoing physical work. Even when you do not notice it, the brain is working, keeping itself within a narrow range of temperatures and chemistry, moving molecules, rebalancing ions, repairing, updating. All of that is energy flow, and energy flow always has a direction. Energy tends to spread out, and as it spreads, entropy increases. So memory, by being a stable pattern, must be paid for. The payment is not money, it is entropy exported elsewhere, usually as heat, usually as molecular motion spread into the environment. This is why memory is aligned with the arrow of time, not because memory is magical, but because memory is physical. Now consider how the brain handles the past. When you recall something, you are not opening a perfect vault. You are reconstructing. Reconstruction sounds uncertain, but it does not need to feel threatening. It is simply a fact about physical systems. A memory is a pattern that can be reactivated. It is not an untouched copy. The brain uses cues, signals, and existing structures to regenerate the pattern, and each time it does, it can subtly modify the pattern. Strengthen certain parts, soften others. This is another way memory shows its physical nature. It changes with use, because it is made of matter. Now let this connect to something larger than the brain. Many of the most important records in the universe exist outside of minds. They exist as light. Light is one of the most extraordinary record keepers, because it can travel enormous distances, carrying information about where it came from. When you look at a distant star, you are receiving photons that left that star earlier. The star does not need to be alive for the record to exist. It only needs to emit light. The light is a physical trace, a stream of particles and waves that encode properties of the source. Brightness, color, spectral lines, tiny shifts, each of these is information. So astronomy is an act of reading records. Even without intending to, the universe has been writing its history into radiation. One of the most remarkable examples is the cosmic microwave background. This is not simply old light in a poetic sense. It is radiation that fills space, a faint glow that is nearly uniform in every direction. It carries information about the early universe, not as a narrative, but as a pattern. Tiny variations, small differences in temperature across the sky, subtle imprints. These are records. They exist because matter and radiation interacted, because the universe expanded and cooled, because correlations were left behind. This is one of the calmest ideas in cosmology. The universe carries a memory of its youth, not in a mind, but in the distribution of light. And again, this memory points backward, not forward, because it was created by past conditions, and it persists as a trace. Now consider fossils. A fossil is a record, not because it represents an animal, but because it is physically connected to one. It formed through processes, burial, pressure, mineral replacement, time. A living structure became part of a rock. The fossil is a correlation between a past organism and present matter. But notice, to create that correlation, the world had to change irreversibly. Sediment had to settle, chemistry had to proceed, structures had to transform. The fossil is not a miracle. It is a thermodynamic process that happened to preserve a pattern. So again, records are islands of structure, created by flows that increase entropy overall. Now, bring this back to the question of why memory only goes one way. If memory is a record, and records are created by irreversible processes, then memory will naturally point in the direction those processes came from. You can only have a record of what caused the record. A memory of tomorrow would require a record created by tomorrow, appearing today, without a cause in today's physics. That would not merely be unlikely, it would violate causation as we observe it. So the future is not missing, it is simply not yet recorded. This is also why we experience the future as uncertain. Uncertainty is not only a feeling, it is a physical fact about what information exists right now. The future contains many possible states, and because the records that would select among them do not yet exist, you cannot know which state will occur in full detail. You can make probabilistic predictions because physics is lawful, and because you have learned patterns. But a prediction is not a record, it is a model. A model can be wrong, and it often must be updated. Memory feels different because it is anchored to traces that exist now, and those traces are the result of actual events, not hypothetical ones. This is the asymmetry between recollection and anticipation. Recollection is reconstruction from physical evidence. Anticipation is projection based on patterns. That is why anticipation can feel anxious. It is not fully anchored, it floats, and that is why memory can feel heavy or solid. It is tethered to what has been recorded. Now notice a quiet implication. If records are physical, then forgetting is also physical. Forgetting can happen in many ways. A memory can fade because a pattern is not reinforced. Molecules turn over, connections weaken, noise accumulates, or forgetting can happen actively. A system can overwrite, prune, compress. In brains, forgetting is not only failure, it is also management. A living system cannot store everything in perfect detail. It must select, it must simplify, it must compress information into useful forms. And compression is a physical process. It involves discarding detail, letting some correlations dissolve. That dissolution is entropy aligned. Erasing information, in a deep sense, means losing correlations. When correlations are lost, the world becomes more typical, more mixed, more high entropy, so forgetting also points in the same direction. Even in machines, erasing is not nothing. It is work, it is resetting states, it is pushing a system into a standard configuration, and pushing things into standard configurations produces heat. This is one reason information theory and thermodynamics are linked. Information is not just abstract, it has physical cost. Now let that stay gentle, not as a deep technical argument, but as a soothing fact. The universe treats patterns as physical things, and the creation, maintenance, and destruction of patterns all occur through energy flow. This is why the arrow of time can be described as a direction in which information becomes harder to retrieve. Not because the past disappears, but because the detailed information about the past is continually dispersed into microscopic degrees of freedom. A cup falls and shatters, and the sound becomes heat, and the heat spreads, and the exact microscopic details become inaccessible. The information is not gone in some metaphysical sense. It is simply scrambled, distributed, hidden in the motions of trillions of particles. And once information is scrambled like this, it does not naturally unscramble. Again, not because unscrambling is forbidden, but because the number of unscrambled states is small, and the number of scrambled states is enormous. So the universe drifts toward scrambled, toward mixed, toward typical, and records are small miracles of structure within that drift, but they can only exist because energy continues to flow. Now bring this gently toward identity. The sense of being a continuous self is built from memory, not only memories of events, but the ongoing record of who you are, habits, preferences, skills, language. All of these are patterns held in the brain, and because the brain is physical, these patterns are maintained through constant activity, constant energy flow, constant renewal. You remain coherent not because you are static, but because your system maintains continuity. Continuity is not unchanging. Continuity is sustained pattern through time, and the arrow of time supports this. Because it allows records to accumulate, because it allows structure to persist long enough to be useful, because it allows the past to remain legible. Without an arrow, coherence would be unstable. Learning would not build reliably. The world would not keep its own history. So in a quiet way, the arrow of time is what makes understanding possible. Now allow that to soften into rest. You do not need to hold your identity tightly in this moment. You do not need to rehearse memories or plan the future. You can let your mind do what it naturally does when it relaxes. Let some thoughts drift away. Let the edges blur. Let the drive to record and track quiet down. The arrow of time will continue, but you do not need to watch it. Records will continue to exist, but you do not need to hold them. And in this calm loosening, there is a gentle alignment with the universe, a warm living system, slowly releasing heat into the night, a mind quietly letting go of what it does not need to carry, and beneath it all, the same steady direction, the past leaving traces, the present holding them lightly, the future remaining open, until it becomes recorded. And you can rest inside that steady flow. Let your mind widen outward now, not as effort, not as a demand to visualize perfectly, just as a gentle expansion, from the scale of a room to the scale of the sky to the scale of the universe itself. Because the arrow of time is not only a feature of everyday life, it is also written into the history of the cosmos. When you look up at a night sky, you are not seeing the universe as it is right now. You are seeing a layered archive. Light has travel time. Some starlight takes years to arrive. Some takes thousands of years. Some takes millions. And light from distant galaxies can take billions of years. So the sky is already a museum of time, a quiet record of how the universe was. And when we speak about cosmic time, we are speaking about changes that occur at a pace far beyond human life. Galaxies forming, stars igniting and fading, clouds of gas collapsing into new suns, black holes growing, the large-scale structure of the universe evolving, all of it is change, and the arrow of time is present in that change. Now here is a subtle point that can feel soothing once it becomes intuitive. Entropy is not only about heat in a room, it is also about the possible arrangements of the universe as a whole, and the universe appears to have begun in a very special condition, a low-entropy condition. This statement can sound strange, because the early universe is often described as extremely hot, and heat can feel like disorder. But entropy is not simply temperature, it is the number of microscopic arrangements available. And in cosmology, gravity adds a twist. Gravity is different from many forces, because under gravity, a smooth spread of matter can be a low-entropy state, and a clumped, structured universe can be a higher entropy one. That can feel counterintuitive at first, so we will hold it gently. Imagine a cloud of gas in space. At first, it may be diffuse, spread out, nearly uniform. Under gravity, small variations can grow. Slightly denser regions pull in more matter, becoming denser still. Over time, that gas collapses, forming stars, forming clusters, forming galaxies. To the human eye, this looks like order emerging from disorder. But thermodynamically, the full accounting includes heat, radiation, and the way gravity allows energy to be released as matter falls inward. When a gas cloud collapses, potential energy becomes kinetic energy, collisions become frequent, the gas heats, and that heat can be radiated away into space. The system is finding a path that increases total entropy, even while creating visible structure. This is one of the quiet beauties of cosmology. Structure does not contradict the arrow of time. Structure can be part of how entropy increases. Stars are not islands of perfect order. Stars are engines. They maintain a gradient, hot core, cooler surface, and they continually radiate energy outward. A star shines, and in shining it spreads energy. It takes concentrated potential and turns it into light streaming into vast volumes. This is entropy in motion. A galaxy filled with stars is not a static sculpture. It is a system of countless energy flows, radiation, dust warmed by starlight, gas cycling between cold and hot phases, stellar winds, supernovae that spread heavy elements outward, and all of those processes generate entropy. So cosmic evolution is not an exception to thermodynamics. It is one of its grandest expressions. Now consider the early universe again. The universe began hot and dense, but also remarkably smooth. There were tiny fluctuations, small variations in density, but overall, the early universe was close to uniform. In ordinary situations, uniformity can correspond to high entropy, like heat evenly distributed in a room. But when gravity dominates, uniformity can be special, because gravity wants to amplify clumping. A smooth mass distribution is like a delicate balance. As time moves forward, gravity makes clumps deepen, structures form, and with those structures, new pathways open for entropy to increase. Stars burn, radiate, and slowly transform matter. So the universe's low entropy beginning is not simply coldness or order in the everyday sense. It is a special arrangement of matter and geometry, a starting point that allowed a long future of increasing entropy. This starting point is still one of the deepest mysteries in cosmology. Why did the universe begin in such a special condition, rather than in a typical high-entropy state? Physics does not yet have a single universally accepted answer. Some ideas connect to inflation, a period of rapid expansion that could smooth the universe. Some connect to deeper questions about quantum gravity, about why there is a universe at all. Some connect to multiverse-style reasoning, where many universes may exist with different conditions, and we naturally find ourselves in one where complex structures can form. But you do not need to settle any of these ideas tonight. It is enough to recognize that the arrow of time, the one you feel in your life, appears to be rooted in the universe having begun in a special state, a state with room for entropy to increase, room for gradients, room for structure, room for change to unfold in a consistent direction. Now let your mind drift outward across cosmic time. As the universe expanded, it cooled. Cooling here does not mean becoming cold quickly. It means that as space grows, radiation stretches, and the energy density declines, expansion changes the environment. It creates more room, more volume, more space for energy to spread into. This is another way the arrow of time is supported. As the universe expands, it creates new capacity for entropy, new space in the landscape of possible arrangements. This can be felt as a quiet widening, like a river that grows broader downstream. In the early universe, matter and radiation were tightly coupled. Light scattered frequently, the cosmos was opaque, a hot plasma of particles. As expansion continued, the universe cooled enough for electrons and protons to combine into neutral atoms. Then, light could travel long distances without scattering constantly. The universe became transparent, and that ancient light, stretched by expansion, is now the cosmic microwave background, a faint glow that fills space. That glow is one of the clearest records of early cosmic conditions. It is also a reminder that the universe's past is still present in traces. Now think of how the arrow of time appears in the lives of stars. A star begins as a cloud, a slow collapse, heating, forming a stable fusion core. Then for millions or billions of years, it converts mass into energy. It shines because it is not in equilibrium. It maintains gradients, and gradients drive processes. Eventually, fuel changes form, the star's structure shifts, its fate depends on mass. Some swell into red giants, some shed outer layers gently, some explode. Some collapse, forming white dwarfs, neutron stars, or black holes. But underneath every pathway, the thermodynamic story continues. Energy spreads, entropy increases. Even a black hole, which can seem like the ultimate order, is, in the language of physics, associated with enormous entropy. A black hole is not a tidy object in the thermodynamic sense. It represents a vast number of possible internal configurations, even if the outside seems simple. So in many ways, gravity and black holes are not opponents of the arrow of time. They are among its strongest expressions. Now consider the long-term direction, the deep future. As stars exhaust fuel, as star formation slows, as galaxies evolve, the universe gradually becomes darker. Not suddenly, not dramatically. On cosmic timescales, the change is slow, patient, almost unimaginably gentle. Even in a far future universe, entropy continues to increase, energy continues to spread, but the gradients become weaker. The most useful way to picture thermodynamic equilibrium at a cosmic scale is not as a single moment, but as a gradual smoothing. Fewer sharp differences, less concentrated energy, fewer bright engines like stars. This is sometimes described as a heat death scenario, but the phrase can sound alarming. In physics, it simply means a future where free energy is scarce, where large gradients are mostly gone, where processes that require strong differences become rare. It is not a violent ending, it is a quiet settling, a universe that has done most of its changing and now changes slowly. Even then, the arrow of time would still exist, because entropy can still increase, but the pace and character of change would feel different. A quieter universe, a more uniform universe, a universe closer to equilibrium. Now remember something important. Equilibrium is not nothing. It is simply no strong gradients. There could still be particles moving, still be radiation, still be quantum fluctuations, still be events, but fewer large-scale processes that transform environments. The arrow of time would still have direction, but less dramatic landscape to traverse. And this ties back to something gentle. The arrow of time is not primarily about speed, it is about direction. The universe can move forward quickly in some places, supernovae, collisions, energetic events, and it can move forward slowly in others, the cooling of a planet, the diffusion of heat, the gradual redshifting of photons. But forward is not fast. Forward is simply the direction in which the overall number of possible configurations increases. Now bring your attention back to the present night sky. When you look up, you are looking into a thermodynamic story. The light that reaches you is the result of gradients, hot stars radiating into cold space, nuclear fusion creating photons that travel outward. The fact that space is cold compared to stars is itself a gradient, and gradients are the fuel of change. Cold space, warm stars, energy flowing, entropy increasing. This is one of the simplest cosmic expressions of the arrow of time. Starlight streams outward, and as it spreads through space, it becomes more diffuse, more dispersed. A photon that leaves a star is highly directed. It has a source, a path, a coherent origin. Over cosmic distances, light becomes part of a broad radiation field, part of the background. The energy is not lost, it is distributed. This is the same story as heat spreading in a room, just on a cosmic scale. And because expansion continues, the universe keeps creating new room for radiation to spread into. So cosmic time is shaped by two cooperating tendencies, energy spreading and space expanding. Both support a forward direction. Now notice how calm this can be. The universe is not rushing toward an ending. It is unfolding. It is exploring its possibilities, from a special beginning into broader and broader typicality. And this unfolding is what gives the arrow of time its deep consistency. It is why the arrow you feel in a breath is connected to the arrow written in galaxies. It is all one direction, expressed across scales. Now let that widen into a gentle stillness. You do not need to picture the entire universe perfectly. You do not need to hold its full history. It is enough to feel the quiet truth that the direction of time is not local to you. It is woven into the cosmos, into the light that reaches your eyes, into the slow burning of stars, into the expansion of space, into the gradual spreading of energy. And because it is so vast, it can also feel gentle, a direction that does not demand hurry, a forward movement that does not require effort, just a patient unfolding. And you can rest inside that immense, quiet direction. Let's continue gently and make sure the remaining ideas settle clearly. The universe began in a special condition, and that specialness is one of the reasons time has a direction. But there is one more part of the cosmic story that is worth holding softly, because it completes the picture of why cosmic evolution is not a reversal of entropy, even when it seems to produce structure. The key is to remember that entropy is an accounting, not a simple visual measure, not just messy versus neat. It includes radiation, heat, and the number of microscopic arrangements available to the entire system, including the environment. So when gravity gathers matter into stars and galaxies, it can look like the universe is becoming more ordered. But the collapse of matter under gravity releases energy, and that energy escapes, usually as radiation. And that radiation spreads out into space. As matter clumps, space fills with light, with heat, with photons streaming in every direction. The net result is not a reduction in entropy, it is an increase, because radiation is an efficient way to distribute energy into many degrees of freedom. A single hot star can radiate into an enormous cold sky. The cold sky represents an immense capacity to absorb and disperse energy. So the universe can build stars and still increase entropy, because the star's radiation disperses energy widely. This is why cosmic evolution is not a violation of thermodynamics. It is thermodynamics operating through gravity. Now notice how expansion changes the cosmic playing field. When space expands, radiation is stretched, wavelengths lengthen, energy per photon decreases. This does not erase energy in a simple, everyday sense, but it changes the way energy is distributed and how it can do work. Expansion makes room for more possibilities, more volume, more phase space, more ways for energy and matter to be arranged. And in that widening, entropy can continue to increase, even as the universe becomes colder in temperature. Cold does not automatically mean low entropy. A cold universe can still have high entropy if its energy is widely dispersed, if it occupies many degrees of freedom. So the far future, a colder universe, can still be a higher entropy universe. That is another quiet counterintuitive point. and it matters. The arrow of time is not warm to cold. It is special to typical, constrained to unconstrained, few possibilities to many possibilities. Now consider again the idea of equilibrium. In an isolated system, equilibrium is where the macroscopic gradients are mostly gone. No strong temperature differences, no strong chemical differences, no strong pressure differences. In a room, equilibrium is a uniform temperature. In the universe, the details are more complex because the universe is expanding and gravity continues to shape structure. But the broad thermodynamic tendency remains. Over time, free energy becomes harder to extract. Gradients weaken. The cosmos becomes less able to run large-scale engines. A star is an engine. It converts a gradient into radiated light. A galaxy full of star formation is a set of engines. As star formation slows, the number of active engines declines. The universe becomes quieter, not in the emotional sense, in the energetic sense, less concentrated energy being transformed into widely dispersed radiation. But even the quiet stage of the universe has processes. White dwarfs cool slowly, neutron stars cool, matter continues to interact, orbits evolve, black holes can grow through mergers, and through all of it, entropy increases. This is why the arrow of time is not just a feature of the early universe. It remains a feature of cosmic evolution throughout. Now let's speak gently about black holes again, because they are one of the places where cosmic entropy becomes especially striking. A black hole seems simple from the outside, mass, spin, charge, but thermodynamically, black holes behave like objects with temperature and entropy. The entropy associated with a black hole is enormous and grows with the size of the event horizon. This means that, in the cosmic accounting, black holes are not anti-entropy objects. They are among the highest entropy structures in the universe. So as the universe forms black holes, and black holes merge and grow, the total entropy budget climbs significantly. This is another way cosmic structure formation supports the arrow of time. And now another gentle detail. When black holes exist, they also connect the story of time to the story of horizons. An event horizon hides information. It hides details about what fell in. From the outside, what was once detailed becomes inaccessible. It becomes part of a simplified description. This is another way information becomes unrecoverable, not because it disappears from existence, but because it becomes effectively beyond retrieval. This connects back to the earlier theme, that time's arrow is closely tied to the dispersal and inaccessibility of information. Now step back again and let these cosmic ideas settle as a single calm picture. The universe began in a special condition, one that allowed gradients, one that allowed structure, one that allowed free energy to be available. From that beginning, gravity amplified tiny fluctuations, creating stars and galaxies. Those structures created immense flows of radiation into cold space, spreading energy, increasing entropy. Expansion widened the arena, creating more space for energy to disperse into, stretching radiation, lowering temperatures, while still allowing the total number of accessible arrangements to grow. And over very long times, the universe drifts toward a quieter state, with fewer strong gradients, not as an abrupt ending, but as a gradual settling. This is the cosmic arrow. Now it can be helpful to dissolve any remaining sense of urgency by remembering scale. Human time is quick, minutes, hours, years. Cosmic time is vast. Stars live for millions or billions of years. Galaxies evolve over immense spans. The universe itself has a long future ahead. So when we speak of the arrow of time at the cosmic scale, we are describing a slow unfolding, not a countdown. The universe is not rushing, it is aging. And aging here is not personal. It is a thermodynamic direction, a gradual shift in what kinds of processes are common and what kinds become rare. Now, allow this to become soothing. Because if the universe's arrow is slow and patient, then you do not need to feel hurried by it. You are a small, warm system in a vast, cooling cosmos, a living gradient for a while. And sleep is simply one of the ways a living system aligns with the larger drift. In sleep, you reduce the need to act, to extract gradients, to do work intentionally. Your metabolism continues, but your mind releases its tight grip on prediction, planning, and constant monitoring. So the idea of cosmic time can gently support rest. The universe moves forward, not as a shove, but as a steady tendency. And in that tendency there is room for calm, because forward is not an emergency. Forward is simply how a universe with entropy behaves: a quiet widening, a slow dispersal, a patient settling. Now, if your mind wants to picture something, picture starlight spreading into darkness, not as drama, but as softness, a warm source, a cold expanse, energy flowing outward, filling space with gentle photons. That flow is the arrow of time made visible, and you can rest as that light continues to travel long after you stop watching it, just forward, just outward, just spreading, with no need for effort. Time is not only something measured by clocks, it is also something felt. You can know the time without feeling it, and you can feel time without knowing the hour. This is one of the quiet mysteries at the center of human life. There is a physical direction in the universe, and there is a psychological experience of flow. Tonight, we let these meet gently, because your experience of time, the sense of now moving, the way minutes can stretch or shrink, the way memory points backward, the way the future feels open, all of this can be described with calm science, without forcing a final conclusion. Begin with something simple. You do not experience time as a raw stream of numbers. You experience it as change. The present is not a single point in physics, but the mind treats it like one. A thin window, a small slice, a moment that feels like this. Then it passes and becomes a memory. The brain is the machine that creates this experience, not because it is a special substance, but because it is a physical system that integrates information over time. Integration is gentle. It means the brain collects signals from eyes, ears, skin, internal chemistry, and it binds them into one coherent scene. That scene feels like the present, but the present you feel is not perfectly instantaneous. The brain uses short windows, it smooths, it predicts, it corrects. This is why you can sometimes feel surprise, because surprise happens when prediction meets something new. Prediction is at the center of psychological time. The brain is constantly forecasting the near future, not as philosophy, not as a deliberate plan. As a basic survival function, if a sound is rising, the brain predicts it will rise a little more. If an object is moving, the brain predicts its next position. If your body is shifting, the brain predicts the next sensations. This is why perception feels stable, because it is partly constructed, and because prediction is always oriented toward what comes next. Your awareness is naturally oriented forward. You do not simply wait for reality, you anticipate it. This anticipation creates a sense of flow. Now connect this to the arrow of time. Prediction works because the world is statistically stable, because the future is not random chaos, it is constrained by physical laws and by the continuity of matter and energy. But prediction is still not memory. Prediction is a best guess based on patterns. Memory is reconstruction based on traces. So the mind carries two different relationships to time, one backward, one forward. Backward through records, forward through simulation. The present is where these meet. This is why the present can feel like a knife edge, a place where what has been recorded meets what is still uncertain. Now let's talk about why time can feel fast or slow, because this is one of the most familiar experiences. A minute can feel long when you are waiting, when you are afraid, when you are bored, when you are in pain, and a minute can feel short when you are absorbed, when you are engaged, when you are in routine. This is not a mystery of physics, it is a feature of attention. Attention is not simply looking harder, it is a selective allocation of processing. When attention is high, the brain samples more, it updates more, it stores more details. More details means more internal events. More internal events means more time markers. So the experience of time expands. When attention is low, or when the environment is predictable, the brain samples less intensely. It compresses, it fills gaps with expectations. Fewer internal markers, less novelty, less change. So the experience of time contracts. This is why novelty stretches time. A new city, a new job, a new relationship, a new kind of day. Your brain cannot predict as efficiently, so it updates more often. It creates more internal landmarks. Later, when you look back, those landmarks make the period feel long. Routine compresses time. Because routine is predictable, the brain runs a smoother model and stores fewer distinct details. Later, when you look back, it feels like it passed quickly. This is one of the reasons adulthood can feel faster than childhood. Not because the laws of physics change, but because the brain becomes better at prediction. and life can become more patterned. Now notice something soothing. Sleep is a state where prediction changes. In waking life, prediction is constantly pressed outward, scanning for what happens next. But as you become sleepy, the brain loosens its grip on the immediate future. The need to anticipate declines. This is not a failure, it is a shift in mode. In sleep, the brain is not primarily tracking the external world, it is turning inward, stabilizing, cleaning, reorganizing. This changes psychological time. During sleep, especially deep sleep, you can lose the sense of duration. You may fall asleep and then awaken, and the hours between can feel like nothing. This is because the brain did not store continuous time markers. It did not maintain a stream of attended changes, so time becomes thin or absent in experience, even though physics never stopped. And when you dream, time can become strange in another way. Dreams can compress, expand, jump, because the brain is not using external cues to anchor sequence. It is generating scenes from internal dynamics. So psychological time is flexible, and that flexibility is one of the reasons sleep is restorative. It releases you from the constant forward pressure of prediction. Now connect this back to thermodynamics, because even the mind's experience of time rests on physical processes. The brain is an energy-consuming organ. It runs on metabolism, on chemical gradients, on electrical potentials. It uses energy to maintain structure, to communicate signals, to store and update patterns. Energy use always produces heat, and heat is entropy spread. So the very act of constructing a present, of building perception, of forming memory, is aligned with the arrow of time. Your sense of time is not floating above physics, it is built inside it. Psychological time aligns with thermodynamic time, because the brain is a thermodynamic system. It cannot remember without changing, it cannot predict without processing, it cannot process without energy flow. And energy flow has direction. Now consider why the present feels special. In physics, there is no universal label that says now. Different observers can disagree about simultaneity depending on motion. But in the mind, now is unavoidable. It is the stage of consciousness. The brain manufactures a present as a functional tool. A present allows coordinated action. It allows you to move, to speak, to respond. The present is a practical interface, a moment-to-moment model. And because the brain is always integrating the recent past and projecting slightly into the immediate future, the present you feel is like a bridge made of neural computation. This bridge is where flow happens. Now the calm part. If you are trying to sleep, you do not need to hold the bridge so tightly. You do not need the present to be sharp. You do not need prediction to be active. In fact, sleep arrives more easily when the present becomes less defined, when the mind stops insisting on precise tracking. So one of the most gentle ways to rest is to allow time to blur. Not by force, not by trying to stop thinking, but by letting attention soften and letting prediction slow, because your brain's sense of time is proportional to how much it is trying to model. When you stop trying to model so intensely, time can feel wide or quiet or distant. This is why lying in bed can sometimes produce a feeling of timelessness. The external world provides fewer inputs, the room is still, the light is dim, the sounds are minimal, so the brain has fewer reasons to update rapidly, fewer updates, fewer markers. Time softens. Now connect this to the arrow of time one last time, in a way that is both scientific and gentle. The thermodynamic arrow gives the universe direction. Entropy increases, energy spreads, records point backward. The psychological arrow gives consciousness direction. Memory points backward, prediction points forward. Both are aligned because both are built on physical processes. And in the quiet of sleep, the psychological arrow becomes less demanding. You are still moving forward in cosmic time, but you are no longer measuring it. You are no longer negotiating with it. You are simply being carried. This can be a restful idea because it means you do not have to keep up with time. Time is not something you must push. It is not something you must solve. It is a direction of change, and you can let it pass through you. Now let attention loosen further. If thoughts appear, they are just patterns. They rise, they drift, they fade. Each thought is a small event in a thermodynamic system, a flicker of neural activity, energy flowing, heat dissipating, entropy increasing. Even thinking obeys the arrow, and now you can let thinking slow. Because sleep does not require you to understand time. Sleep only requires you to stop resisting the natural shift from active prediction to quiet restoration, from sharp present to soft present, from tracking to letting go. And as you let go, time becomes less like a line and more like a gentle current, still moving forward, always forward, but with no need to watch it, just resting as the universe continues its patient drift. You do not need to solve time, to rest inside it. You have already done something quietly rare tonight. You have looked at the direction of the universe without turning it into a problem. You have let it remain what it is, a steady tendency, a gentle drift, a consistent unfolding. And now the mind can loosen, because the arrow of time does not ask for your attention. It does not require your agreement. It moves forward whether you watch it or not. In thermodynamics, forward is the direction where entropy increases, where energy spreads, where gradients soften. In life, forward is the direction where records accumulate, where memories form, where the present becomes the past. These are not separate stories. They are two descriptions of the same direction, one seen from the scale of atoms and one seen from the inside of a mind. It can be calming to remember that time is not something you must push. You do not move the universe forward. You are carried with it. Even your effort, even your planning, even your worries have always been happening inside that larger drift. And now you are allowed to let those soften. You can let the future remain unmade, unrecorded, open. You can let the past remain where it belongs, as traces, as patterns, as quiet correlations in matter. You can let the present become less sharp, because sleep does not need a sharp present. Sleep is what happens when the mind stops insisting on tracking, when attention unhooks from prediction, when the stream of inner narration becomes less necessary. Now, if a thought appears, you can treat it as a small physical event, a pattern of activity, rising, moving, dissipating. It will pass, because everything passes. That is not a loss. It is simply the direction of change. And beneath each thought, the body continues its quiet work, breathing, circulating, releasing heat, a warm living system, exchanging energy with a cooler room. Even now, this is the arrow of time made simple. Warmth moving outward, a gradient gently relaxing, no urgency, no drama, just physics. And because it is just physics, it can feel safe. The universe is not demanding a conclusion, it is only moving. And in that movement, there is continuity, a strange kind of comfort in knowing that everything you are, every sensation, every memory, every moment of awareness is part of a larger, lawful unfolding. Now return to the simplest observation. There is a direction to everything. Spilled water spreads, smoke diffuses, heat moves from warm to cool. Records point backward. You did not choose this direction, but you can rest inside it. You can let your mind stop bracing against it. Because forward is not an instruction, it is not a command. Forward is simply what happens. When there are more ways for things to be mixed, then there are ways for them to be neatly arranged. Forward is the statistical slope, from rare to common, from constrained to typical. And you are not separate from that slope. You are a small local pattern, maintained for a while, a brief island of structure running on gradients shaped by energy flow. And now, in sleep, you can let some of that structure loosen in the most natural way, not collapsing, not ending, just releasing. Let the mind stop trying to hold the whole universe. Let it become enough to be here in the simplest physical sense. Breath, warmth, gravity holding you down, the room holding you softly, time moving forward without needing you to monitor it. And if you imagine anything, imagine starlight, not as a spectacle but as a quiet fact. Photons leaving a star, spreading into wide space, becoming more and more diffuse. Not lost, just distributed. That gentle spreading is the arrow of time, written in light. And you can let yourself drift the same way, not lost, just relaxing, not disappearing, just releasing the need to track. Forward continues, but you are allowed to rest inside the direction of everything.